Hey everyone, and welcome to the course. My name is Daniel Buckley and I'll be your instructor. In this course, we are going to explore 4 different mini projects within Godot. Each of these projects are going to teach us something new about the engine and help us in the future to create our games. So let's have a look now at the 4 different mini projects that we'll create. So the first one is going to be a balloon popper. This is going to be a little game where there's going to be balloons on the screen that when we click on them, they're going to increase in size. Then once they reach a certain threshold, they will pop and increase our score. In this mini project, we are going to be exploring mouse clicks as well as importing 3D models, UI, and a bunch of other stuff. The next mini project is going to be looking at Godot's physics in a 2D environment. We're going to have a player where if we click on the screen, they are going to essentially jump in that direction. They're going to slide off in that direction, and we're going to litter the scene with crates, which are also going to be physics objects that are going to react to their collision and their movement and their forces. The next mini project is going to do with collision detection. We're going to have a little downhill skiing mini game where the player can move left and right with the arrow keys, and when they hit a tree, that is going to restart the level. So we'll look at how we can detect collisions with other objects and know when we are hitting specific objects. And then finally, we are going to be looking at loops. Now, loops are more of a programming or coding focused system, but we are going to integrate them within the engine by actually spawning in a star system. Okay, we're going to look at, first of all, creating 1 star in the night sky, and then look at how to create hundreds or thousands of more by only writing about 1 extra line of code. Okay, loops are pretty powerful. Now, in terms of course requirements, a basic understanding of Godot and GDScript is required. Now, I'm not going to be expecting you to understand exactly what everything in the engine or everything in GDScript is. That is not a requirement at all. The requirement is just that you have gone ahead and learned the very basics of how to use the engine and how to code in GDScript. So you know the concept of a variable, you know the concept of a function. You may not exactly know the nitty-gritty of how they work, but don't worry, we will still be going line by line very carefully whenever we are writing code, and we'll also be taking it slow and explaining exactly what we are doing when we are navigating the editor. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with the first lesson. Hey everyone, in this lesson we are going to begin setting up our balloon popper minigame inside of Godot. So our balloon popper game is going to be a bit like this. We are going to have a number of balloons on our screen and we'll be able to click on them with our mouse. When we click on a balloon, it will inflate in size, and then once it reaches a certain size, the balloon will pop and our score will increase by 1. We are also going to have a UI text element on screen at the top left corner, which is going to be displaying our current score. So, what are we going to learn in this mini project? Well, there are going to be 3 main things that we are going to explore. One of them is going to be input events, being able to detect when an input has occurred over a specific node, in our case, when our mouse has clicked on a balloon. We'll also be looking at UI labels. These are UI elements that allow us to display text, buttons, images, whatever you want onto your screen. And we'll also be looking at how we can communicate between scripts. Okay, we are going to be creating 2 scripts in this project, one called Balloon, which is going to manage clicking on the balloon and increasing its size, and then another script called Balloon Manager, which is going to be in charge of maintaining the score and updating the text. So now let's get started in creating our game. So here I am inside of the Godot project manager, and what we're going to do is create ourselves a brand new project. So at the top left corner, I'm going to click on the create button, and then we have the create new window appear. Here we can give our project a name. So I'm going to call this one, let's just call this one Godot mini projects course. Okay, there we go. Then we can choose our project path by clicking on browse. I like to have a dedicated folder on my computer for my Godot projects, so I'm going to navigate there now. Okay, and then everything else we can keep as is default. Next, we can click on create, and that should close down the project manager and open up the editor. And here we are inside of Godot. Okay, we have a brand new empty project. Now, before we start creating our scenes, creating our balloons, our scripts and all of that, what we're going to do first of all is import a model for our balloon, because we could simply use a sphere for our balloon, but I've gone ahead and created ourselves a brand new model for the balloon just so it looks a bit nicer. Now, the way I'm going to organize this down in my file system is by having a folder for each of the mini projects we are going to create. So since we are now working on the balloon popper, I'm going to create a new folder called balloon popper. So to do this, we can simply right click in the file system at the bottom left, go new folder, and call this one balloon popper. And there we go, we have balloon popper. Now what we need to do is import that balloon model. Now, if you want to use the models, the textures, and everything that I am using in this course, then if you go over to the course files tab, there should be a downloadable zip containing the assets for this course. Now, once you download that zip file, I want you to extract the contents to your computer, and inside you should see 4 folders, okay, one for each of our mini projects. Now, inside of these folders, they don't contain the projects, but rather the assets that we will be using for the project, okay, such as sprites and 3D models. Now, if we go over into the balloon popper folder, you should see there is a balloon material and a balloon OBJ file, which is a 3D object. What I'm going to do is select both of these and drag them into my file system here. And what that should do is import the models, and if I open up the balloon popper folder now, you should see we have a balloon.obj file here. And if I go ahead and double click on it, you should see in the inspector, we have a little overview of what this file contains. And here inside of the little viewport, we can actually see the gray balloon model. Now, in the future, we will be creating materials to change what this balloon looks like. So we'll have a nice red one, maybe even a green material. It's entirely going to be up to you. Now, the next step is going to be creating our scene, okay? And the scene is what's going to contain all of our balloons, our scripts, our UI, and this is what the game is going to run. So what we're going to do is on the left-hand side in our scene doc, this is where we basically have a list of all of our nodes, but before we can see our nodes, we need to create our root node. And the root node is going to basically define what type of scene we are making. Now, since we are using 3D models, this is going to be a scene that is set in 3D space. So I'm going to select 3D scene. And there we go. So we have our root node created, which is going to be the parent of all the other nodes that will eventually be created here. And what I'm going to do is rename this root node by double clicking on it. And I'm going to rename it to be main. Okay, this is just a general practice I like to follow, having all of my root nodes be called main. Now we can go ahead and save this scene to our file system by going up to scene, save scene, or Control S. Then we can navigate over to our balloon popper folder and save this scene as balloon popper. Okay, so balloon underscore popper is what I'm going to call this scene, and then just save it like so. So now we can open up the scene whenever we wish. And if we go up to the top right corner here, we can click on the play button. Now, since we have no main scene currently defined, it's going to ask us if we want to select the current scene, which is Balloon Popper, to be our, going to basically define what time our scene is going to run. So what we're going to do is on the left hand side in our scene doc, this is where we basically have a list of all of our nodes, but before we can see our nodes, we need to create our root node. We are making that is set in a root node created. We are going to rename it to be main, okay, main. Save scene or Control S. Then we can navigate over to our Balloon Popper folder and save this scene as Balloon Popper. Okay, so balloon underscore popper is what I'm going to call this scene, and then just save it like so. So now we can open up the scene whenever we wish, and if we go up to the top right corner here, we can click on the play button. Now, since we have no main scene currently defined, it's going to ask us if we want to select the current scene, which is Balloon Popper, to be our default scene. So we'll go select current. Now, whenever we launch the game, it is going to launch inside of the Balloon Popper scene, okay? So once that loads up, you can see we now have our empty scene rendering right here. Okay, so we have our empty scene, but let's add something in so, we might actually be able to see something. And to do that, we are going to be creating our balloon model. Now, what we can do is go ahead and create a brand new mesh instance 3D node, which can then represent a model. But an easier way of including our model in the scene is simply by clicking and dragging it from the file system into our scene here. That is going to automatically create a mesh instance 3D node and assign the balloon mesh to the property right here. Now, if we save that and press play, you'll notice that once again, we don't really see anything. And that is because we do not currently have a camera in our scene, okay? If we want to be able to render anything inside of a 3D scene, we need a camera. Otherwise, we aren't really seeing anything, okay? It's essentially as if we're having our eyes shut. So what we're going to do is we are going to go to the top left corner of our scene doc, click on the plus to add a new node, and I'm going to search for camera 3D right here. Click create, and that is going to create the camera right here. Now, we can then move this camera around, and you can see we have this little pink lines basically representing the viewport. And with the camera selected, if we look over in the inspector, we can see a little preview of what the camera is actually seeing. So if I position the camera so that the balloon is in the center right here, we can save that, press play, and now we can see our balloon is in view. But there's a few issues. First of all, our background is gray and the balloon is completely dark, okay? So what we need to do in the next lesson is add in a light so we can actually see our balloon, as well as adding a material onto our balloon so that it can actually have a nice color that pops out at us. Now, as a bit of a challenge between now and the next lesson, I want you to go ahead and try and add in the directional light and position it in a way so that the balloon is basically having its face that we can see here lit by the sun, which is essentially what the directional light acts as. So have a go at that, and I'll be right back to see you. see how you're done. Welcome back, everyone. I hope you had a go at that challenge. So pretty much what we need to do is add in a new node to represent our directional light. Now, what we're going to do is go up to the Add Child Node button here, and we are going to search for Directional Light 3D and create that like so. Now, I'm just going to move it up a little bit, just so we can more easily see the arrow, but the position of the directional light does not matter. We can have the directional light up here, down here, or anywhere we want. The position doesn't matter. All that matters is the rotation, which, as you can see, based on the arrow, defines the direction the light is pointing in. So, if we begin to rotate this light around, you can see that on our balloon here, we can kind of exactly pinpoint where this light is going to point. So maybe something like this. If I save that and press play, now you can see that the light is appearing on our balloon, which is great. But something else we might want to do, and that is to change the visuals a bit. Okay, you can see that our shadow is very dark and we have a gray background. So how can we fix that? Well, we can fix that by using a node known as World Environment. Now, the World Environment node is very powerful and has a lot of different things for us to modify, but we're not going to be spending too much time looking at every single aspect, okay, as that can take hours potentially. So what we're going to do is we're going to create a new node here, look for World Environment, and create that. Now, when we create the World Environment node, you'll notice that our background here inside of the editor suddenly goes gray. And the reason why is because before, our viewport here was using a World Environment node, but just to render the viewport here. Okay, when we press play on our game, it goes back to the default, which is no world environment. So when we go ahead and create a brand new one, it overrides whatever was originally there, so we can now customize the look. Now, what we're going to do is make it so that our background is a different color than gray. So first of all, we need to create our environment resource. So if we go over to the inspector, you'll see we have the environment property, and currently it is empty. So I'm going to click on the little arrow here and go new environment. Now, if we click on the environment that was just created, it's going to open up this list of all the different things we can modify. Okay, we can modify our lighting, our ambient occlusion, glowing, fog, adjustments. There's so many things here to experiment with, and I recommend that you go through and just play around with all of these settings. But for now, we are just going to go to background. And at the moment, background mode is set to clear color, which basically means it's not rendering anything for the background. So I'm going to change that over to custom color. Now, by default, it's going to be black, so that's why our background suddenly changed. I'm then going to click on the color here, and I am just going to change this over to HSV, hue, saturation, and value. So we can then modify our color here to be a nice blue. Something like that. We can then change it around here on the color wheel. Maybe a nice blue, something like that. There we go. And now, if we press save and then play, you'll see that our balloon looks a lot nicer here with the blue background, and even the black shadow that was here before is now having a little bit of a blue tinge because it is taking into account the background of our scene. Okay, so the object looks more, I guess, belonging to our game right now. But the next thing is, of course, going to be giving our balloon a bit of a visual color, because right now a gray balloon is a bit boring, okay? Balloons are normally very vibrant colors, so we are going to be setting that up. Now, to create a color for our balloon, we have to create a new resource known as a material. Now, materials basically define the properties or the visual properties of a 3D model, such as its color, its texture, how reflective it is, how rough it is there any glowing, is there any other elements that we might want to apply to change its visual look. So what I'm going to do is down here in our file system, I'm going to select the balloon popper folder, right click on it, then go create new, then down to resource, okay? Now what we want to do is basically search for material, and you'll see there are a number of different material resources we can create. What we want to create is going to be known as a standard material 3D. This is essentially a material we can apply to a 3D model. So I'll click create. We then need to give it a name. So I'm just going to call this one balloon underscore, and we'll go red, okay, because this is going to be our red balloon material. Click save. That material is then going to be created inside of our file system, and with it selected, you'll see in the inspector we have all of these different properties to modify, okay? Now there are a lot of stuff to go through in this list. We aren't going to go through even probably 5 or 2% of it, okay? There is just so much to go through, but we are only going to be looking at a number of things, okay? And that is going to be albedo, which is going to define the color, and then roughness, which is going to define how reflective the balloon is. So we can see a little preview up here, which is nice. And what I'm going to do is go to albedo. I'm going to select it, and I'm simply going to find a nice red color, okay, something like that. Actually, we'll make it a bit lighter, something like that. There we go. Next, what we can do is go down to roughness, and right now you can see the roughness is set to 1, which is basically 100% rough. Now, if I bring this down, you can see in the little preview image that the material is becoming more reflective, okay? Now, balloons, they are made of rubber, and when stretched out, you know, sometimes they can be quite reflective. So I'm going to bring this to around 0.4. Now, we have our material visible up here in the preview, but it's not currently in our scene. So how do we actually apply this material to our model? Well, there are multiple ways. The easiest way is to select the model in the file system, click and drag it over the model and let go. Okay, easy as that. The second option is to select our model. Then in the inspector, if we go down to geometry, you'll see there is a material override property, which we can simply drag in that balloon red to the field here. But since we already applied the balloon red material, that is why it is already here, okay? And there we go. Now we have our red balloon material. So we can save that. Override property. The second option is to select our model. Then in the inspector, if we go down to geometry, you'll see there is a material override property, which we can simply drag in that balloon red to the field here. But since we already applied the balloon red material, that is why it is already here, okay? And there we go. Now we have our red balloon material. So we can save that, press play, and we should be able to see our balloon in game. Okay, so now that we have our background, our light, and our balloon material set up, in the next lesson, we are finally going to be looking at setting up the script and the nodes required to have our balloon increase in size whenever we click on it. So thanks for watching, and then play. You'll see background more balloon for our balloon prop. I'm going to select the balloon popper folder, right click on it, then go create new, then down to resource, okay? Now what we want to do is basically search for material, and you'll see there are a number of different material resources we can create. What we want to create is going to be known as a standard material 3D. This is essentially a material we can apply to a balloon material. Is then you'll see into modify one. We then need to give it a name, so I'm just going to call this one balloon underscore, and we'll go that with it to modify. We aren't very much to go the balloon in. I'm going to select is then going to be with it select these different properties to modify. A lot of stuff to go, so we aren't probably % of it, okay? There's so much to go, number of which is going to define the N reflective, and it's nice, a nice in the preview, but it's not currently in our scene. So how do we actually apply this material to our model? Well, there are multiple ways. The easiest way is to select the model in the file system, click and drag it over the model and let go. Okay, easy as that. The second option is to select our model over here. It requires your Welcome back, everyone. In this lesson, we are going to be setting up our balloon so it can actually begin having the ability to be clicked. Now, before we jump into creating a script, we first of all need to change our node a bit, because right now for our balloon, we just have this mesh instance 3D node, which is great, but it has one big issue, and that is it has no way of detecting when our mouse is going to click on it, okay? The reason why is because, first of all, it doesn't have a collision shape, so it doesn't actually know, what to check. And second of all, it is not of the right node type. Now, the node that we want to use is what is known as an Area 3D. Now, an Area 3D node, you basically have to give it a collider, and that collider is not going to bounce off objects or prevent objects from moving through it. Rather, the Area 3D is acting as sort of a trigger, okay? So if you were to have a game, for example, you might have a portal be an Area 3D, so when the player walks through it, they might get teleported away. In our case, we are going to use this Area 3D to detect when we are clicking on the balloon. So how do we do this? Well, first of all, we need to create a new node of type Area 3D, just like that. So we'll create that right there. I'm then going to rename this Area 3D to be Balloon. So just double click on the Area 3D name and write in Balloon. Now it's called Balloon 2 because we already have a node called Balloon. So what I'm going to do is rename the model to just be Model, and rename balloon to be balloon. Now you'll see there is this little warning notification here next to the node. That is basically telling us that this Area 3D is not really going to work in the way we want it to unless we add a collision shape 3D node which defines its collision shape. But before we do that, let's go ahead and drag in our model as a child of balloon so that whenever we move around the balloon node, so too will the model follow along. And just make sure on the model, if we go down to the transform properties, make sure that the position is set to 0 on the X, 0 on the Y, and 0 on the Z. This means that the balloon model is now centered to its parent Area 3D position, okay? So let's go ahead and create that collider now. So I'm going to right click on balloon, I'm going to add child node, and I'm going to search for a collision shape 3D. Now, with this collision shape 3D, we have to go over to the inspector and give it a shape property. The shape property is basically going to define what this collider is going to look like. So we have spheres, boxes, capsules, cylinders. For us, I think the best and simplest one is just going to be a sphere. So I'm going to click on New Sphere Shape 3D. And if we zoom in close enough, you can see that there is this blue outline of a sphere. If we click and drag on this little orange node that has appeared, this is going to allow us to change the size or the radius of the collider. So I'm just going to make it about that big. We can look at a side view here. So I'm just going to adjust a little bit, maybe even move it up so it's more in the spherical region of the balloon. Something like that. Okay, and there we go. So now we have our rough collision shape around our balloon. It doesn't have to be exact. And next, we need to go ahead and create a script that can then run the code needed. So I'm going to select our Area 3D balloon, and then in the inspector, I'm going to go down to the bottom where it has the script property. And here, I'm going to select it and then go New Script. We are then going to make sure we are saving it to our balloon popper folder. And I'm going to call this script balloon. Okay, we can then click create. And inside of this script, we are going to do a number of things. We're first of all going to have a function that is going to be called whenever a certain event has occurred on the balloon, okay? So how can we set that up? Well, it's not a function we would just want to write out right here, but rather it is what is known as a signal. Now, if we select our balloon with the Area 3D balloon and go over to the inspector, you'll see at the top there are 3 different tabs we can choose from: Inspector, Node, and History. Well, we want to go over to the Node tab and make sure that the Signals window is selected here. Now, what you are looking at is a list of all the signals that this node can emit. Now, what is a signal? Well, a signal is essentially like an event, okay? It can be something that the node emits out to the world. For example, when another area has entered this area 3D, it will emit that signal. When a mouse cursor has entered the collider, it will announce that signal. When the visibility has been changed, so is it visible or is it not visible, that is being emitted. And what we can do is connect these signals to a function inside of a script. So when this certain signal has been emitted, a function will be called. Now, the signal we want to connect to is this one here, input_event. Now, input event is basically going to be emitted when an event has occurred in the space of the balloon, okay? So for example, when our mouse cursor is over the balloon and we click on it, that means this function or this signal is going to be emitted. Now, let's connect this to a function inside of our script here. Now, to do that, I'm just going to double click on the input event signal. And then in this list here, it says connect to script. So we're going to go down, select our balloon, which has that balloon script. And down here, you'll see receiver method. This is essentially the name of the function that it's going to create. So if we click connect, you'll see that a new function has been created inside of our balloon script. Okay, now we're not going to be modifying this function just yet, but first of all, we are going to be creating 3 variables. The first one is going to be a variable called clicks_to_pop, and it is going to be of type integer, so int, and we'll set its default value to be, let's just say 5. Now, clicks_to_pop is basically going to determine how many times we have to click on this balloon in order for it to pop. And each time we click on it, it is going to increase in size. Now, how much is it going to increase in size? Is it going to increase 5%, 2%, 20%, 50%? Well, we are going to create a variable for that right here as well. So create a variable called size increase. And this is going to be of type float, so a decimal number, and we'll make it 0.2. Now, the way we are going to increase our balloon is going to be changing its scale. So if I select my balloon here, go back to the inspector, go down to transform, you'll see here we have the scale property, which at the moment by default is set to 1. Now, if I change this to, for example, 1.1, you can see the balloon has increased a little bit. If I make it 1.2, it's increased a little more. So essentially, every time we click on the balloon, we are going to increase it by that size increase amount, which is 0.2. So for example, if we click on the balloon for the first time, we're going to make it 1 plus 0.2. So it's going to be this large. And then when we click it again, it's going to be 1.4, then 1.6, etc., etc. Okay. So now let's write down our last variable. The last variable we're going to create is one called score to give. And this is going to be of type int, and we're going to make this equal to 1. This is essentially going to be how much score is this balloon going to give to the player when it has been popped. Now, we are having this as a variable because we might want to have different balloons give different scores. We also might want different balloons to give different size increases and different balloons to give different clicks to pop. So how can we do that if we are hard coding these values inside of the script? Well, we can add a tag to the start of the variable declaration, which goes at, so that symbol, shift2, export. Now, export basically makes it so that this variable is now visible inside of the inspector. So you can see here, clicks to pop is now a variable that we can modify, just like with all these other properties. If we go ahead and do that to the rest of our variables here, export and export, you can see we can modify them here. So if we were to make a copy of this balloon and then modify the clicks to pop, that modification is only going to be present on that duplicate of the balloon. So we can have different balloons with different clicks to pop. We might have one balloon that could increase its size twice as fast, one that increases it half as fast, and different balloons can give different scores. Now, in the next lesson, we are going to begin working on the onInputEvent function. So thanks for watching, and I'll see you. See you all then. Welcome back, everyone. In this lesson, we are going to be detecting when we are clicking on our balloon. Now, we are going to be doing this down in the onInput event function. Now, the first thing you may notice is that there are a lot of parameters that this function is sending over to us, okay? And the reason why is because this function isn't just for mouse clicks, okay? This can also be called when there's keyboard inputs, when there is controller inputs, when there's any sort of input. This function will be called. So what we need to do first of all is filter out any and all inputs that are not specifically what we want. So there are going to be three things that we are going to check to make sure is true. The first one is going to be checking to see if the event that was sent over has to do with the mouse buttons, okay? If it has nothing to do with mouse buttons, then we don't want to run this function and we want to stop the function there. The second one is going to then be checking to see if the button that was clicked was the left mouse button. If the left mouse button wasn't clicked, then we don't want to run this function. And then finally, we are going to check to see if the event was tagged as pressed. And pressed basically means that was this the frame that the button was pressed down. If this was not the frame the button was pressed down, then we don't want to run the function, okay? But if all three of those conditions are true and we've reached the end, then we are going to run the code to increase the size of the balloon. So first of all, we need to stop running the function if this is not a mouse button event. So for this, I'm going to go if event, which is one of the parameters that gets sent over, and event basically is an object that contains a bunch of information about what currently happened. So here we're going to go if event is not input event mouse button, okay, just like that, then we're going to return. So basically, if the event that occurred is not of type mouse button, then we don't want to run the rest of the code in this function, so we are going to return. Now remember, code gets run from top to bottom. So when this function is called, we first of all run line 8 right here, then we run 9, then 10, and so on and so forth. So if we call return here, that basically means the function is ending here, and we are no longer going to run the rest of the code in the function. But let's just say, okay, this is a mouse button event. Well, then what we need to check to see is if this button is the left mouse button, okay? But if it is not the left mouse button, we want to return as well. So here we'll go if event dot button underscore index, which basically is going to give us the button that was pressed. If this does not equal, so exclamation mark equals, mouse button left, you can see it pops up here with the different options, mouse underscore button underscore left, then we are going to return. So if we are pressing the right mouse button, return. If we're pressing the middle mouse button, return. If we're pressing the left mouse button, then this condition is going to be true, thus return is not going to be called, and we will move on with the rest of the function. Then finally, we have one more condition to check, and that is whether or not the event was pressed. So here we'll go if not event.pressed, then return. So we only want to run this function if the event was pressed down this frame. And if we pass all three of these conditions, so if it is a mouse button event, if we did click with the left mouse button, and if the event mouse button was pressed, then what we're going to do is, for now, just print out a line to the output, which is just going to say increase size, okay, just like that. So let's go ahead and press play and see if it works. So I'm going to press play. I'm going to move my viewport up a little bit so we can have a look down here at the output. And then if I click out here on the blue, you can see nothing happens. But if I click on the balloon, we have increased size being called, which is great. If I try and right click, nothing happens. If I middle mouse, nothing happens. If I hover over with my mouse and start pressing keys on the keyboard, nothing happens. Only when I click with the left mouse button do we get that print sent to the output. Now, what we need to do is basically increase the size of our balloon. So how do we do that? Well, what we are going to do with our balloon here is access its scale property. Now you can see scale has an X, Y, and Z value. So this here is what is known as a vector 3. It basically contains 3 values, X, Y, and Z. And we basically want to increase each of those, the X, the Y, and the Z, by our size increase. So the balloon is going to basically grow uniformly in all directions. So I'm going to delete the line of code where we are printing, and I'm then going to go scale, which is that scale property right here. If we hover over it, you can even see it says in this little pop-up on the left, property scale. We are then going to go scale plus equals. So we want to increase scale by whatever we have on the right-hand side of that symbol. And that is going to not be size increase. Okay, so if I write plus equals size increase, this is going to return an error because we are trying to increase a vector 3 by a float, which those two data types do not mix. So instead what we're going to do is we are going to go scale plus equals vector3.1. Now vector3.1 is basically a vector which has 1 on the X, 1 on the Y, and 1 on the Z. So since we are increasing a vector by another vector, we have no errors and it should work. So if I go ahead and press play and click on the balloon, you can see it is going to increase by 1 in scale each time I click. But there's one issue here, and that is we don't want it to increase it by 1. We want to increase it by, at the moment, 0.2, as is defined by the size increase. Well, since this vector3.1 has 1 along all axes, if we then multiply that by the size increase, this is going to basically give us a vector here that is 0.2 on the X, 0.2 on the Y, and 0.2 on the Z, okay, because we are multiplying 0.2 by 1 on the X, 1 on the Y, and 1 on the Z. So if I save that, then press play, you can see that when I click it, it now increases by 0.2 every time I click, which is very nice. Okay. Now, next up, what we need to do is make it so that once we have clicked on the balloon 5 times, it will pop. So how can we do that? Well, essentially what we're going to do is basically subtract 1 from the clicks to pop variable every time we click on the balloon. So to do that, we can go clicks to pop minus equals 1. So whenever we click on the balloon, it is going to decrease it by 1. And then we can have a if statement down here which checks to see if clicks to pop is equal to 0. So here we'll go if clicks to pop equals 0. Then what we want to do is destroy the balloon. We want to delete it from our scene. And to do that, we can simply call the queue_free function here. Queue_free is essentially just going to delete the node that this script is attached to, which is our balloon node. So if I save that and press play, you should see after 5 clicks, 1, 2, 3, 4, 5, the balloon is destroyed, okay? And that is our balloon increasing in size and then popping. Now, in the next lesson, we are going to be looking at setting up our score with our UI. But before we do that, let's just quickly go over what we've done so far. So we have the onInput event function, which gets called whenever an input occurs on top of the balloon, such as if our mouse is over the balloon and we click, the onInput event function will be called. Now, we don't want to increase the size of the balloon if we are right-clicking or if we are pressing a key on our keyboard, so we are adding in these 3 filters. Basically, if the event has nothing to do with a mouse button, then we are returning. We are ending the function here. If the button that was clicked was not the left mouse button, so if we clicked the right button, the middle button, one of the side buttons, then we are also returning. And then finally, if the button was not pressed, we are returning. Okay, we only want to run this code down here if we clicked down with the left mouse button. Now, in the next lesson, like I said, we'll begin working on our scoring system. So thanks for watching, and I'll see you all then. is very nice. 0.2 here, and that vector 3 the output, and then if I click out here on the blue, you can see nothing happens, but if I click on the balloon, we have increased size. We are going to do we have no errors, and it should work. To increase it by and to do that, we can simply call the Q-free function here. Whenever an input occurs on top of the balloon, such as if our mouse is over the balloon and we click, the onInput event function will be called. Now, we don't want to increase the size of the balloon if we are right-clicking or if we are pressing a key on our keyboard, so we are adding Now, if we select our balloon with the so I'm just going to adjust a little bit, go over to the so that whenever we move around the balloon and rename balloon just like that, so we'll create that right there. I'm then going to rename this Area 3D to be balloon, so just double click on the Area 3D name and write in balloon. Now it's called our notification here next to the node. That is basically telling us that this Area 3D is not really going to work in the way we want it to unless we add a collision shape 3D node, which defines it as a child along, means that D. Now with this collision, create that collider now 3D Z. Make sure that the position and just make around and drag in our model as a child of balloon so that whenever we move around the balloon node, so too will the model follow along. And just make sure on the model, if we go down to the transform properties, make sure that the balloon model is now. So let's go ahead and create that collider now. a collision shape and give it a shape property. The shape property is basically going to define what this collider is going to look like. So we have spheres, boxes, capsules, cylinders. For us, I think the best and simplest one is just going to be a sphere. So I'm going to blue outline appeared. This is going to allow us to check out that big. We go in the spherical region of the balloon, something shape around our balloon. It doesn't have to be exact. Run the code needed. So I'm going to select our Area 3D balloon, and then in the inspector, I'm going to go down to the bottom where it has the script. We are then going to make sure we have the script of the script function right. You'll see strings or well a something's error entered visible or is it not visible? Emitted is this going to be case function inside and then balloon or the name has been function that is going to create. So if we can function and to be to click what's inside to the very. So essentially, every time we click on one form, if I want a good example, if we click on the going to be this a give going to be when it scores. Clicks the option. Now export basics of this and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be detecting when we are clicking on our balloon. Now, we are going to be doing this down in the onInput event function. Now, the first thing you may notice is that there are a lot of parameters that this function is sending over to us, okay? And the reason why is when there's keyboard input is make sure event function was pressed on the one of them contains a bunch of data you're going to return. Now remember, if we tracked, I say ending the like I said, we'll begin working on our welcome back, everyone. In this lesson, we We are going to be looking at setting up our scoring system, because right now we can click on our balloon, increase it in size, and have it pop. But at the moment, we don't have any way of actually increasing our score. We are simply destroying the balloon when it pops. Now, our scoring system is not going to be managed on the balloon itself, okay? We aren't going to have a score variable here in our balloon script, because if we increase that and then pop the balloon, well, that score is just going to disappear with the balloon. So what we need to do is create a separate script that is going to manage our score. And this script is going to be attached to another node. For this example, we're going to make it our root node here. So what I'm going to do is select our root node, main, go over to the inspector, and attach a new script. And this one we are going to call balloon manager. Okay, and we're going to save this in the balloon popper folder. I'm going to click create, and here we go. Now, inside of the script, we are going to have a variable to keep track of our score. So I'll create a variable called score. This is going to be of type int, and by default, it will be equal to 0. Then we are going to have a function that we are going to call whenever we want to increase our score. So I'm going to create a function called increase score. And this function is going to have a parameter of type amount, which is going to be of type int. Now, we are having this because we might want different balloons to give different amounts of score. So inside of this function, we're then going to go score plus equals amount. So we're increasing score by amount. And then we might want to print this out to the output just so that we can see what our new score is. So here I'll go print score. So this is then going to print out the number to the output window down here. Okay, now how do we actually, in our balloon script, is going to be of type whenever we want to increase. And now we are having this because we might want different balloons to give different amounts of score. So we're increasing score by amount, and then we might want to print this out to the output just so that we can see what our new score is. So here I'll go print score. So this is then going to print out the number to the output window down here. Okay. Now, how do we actually, in our balloon script, call this increase score function? Okay, how do we do that from a different script? Because we can't just call that function here by going increase score. This script isn't going to recognize that function as existing because it's going to search this script for the function name. So what we need to do is we need to create a reference to that main node which houses the balloon manager script. So we're going to do this by, first of all, creating a variable at the top of our balloon script here called manager. And then inside of the ready function, which gets called when this node is initialized, so we'll go func ready. Inside of here, we simply want to go manager equals, and then we want to create a reference to the main node which holds the balloon manager script. So I'm just going to click and drag that node into our script here, and it should then input this $, and then in a string it's going to have the path to that given node in the scene hierarchy. And this is just what it is to reference the main node right here. So now what we can do is down here, before we destroy the balloon with Q3, I am going to go manager and then dot, and we can then call a function, or we can access the score variable, but I'm going to go increase score. We can then give it our score to give variable, which is the amount of score we give when popped, and that should then work. So I'm going to save that, press play, and see if it works. So keep an eye on the output down here for a number to pop up when I pop the balloon. So I'll click on the balloon, and there we go. It says 1. Now, that is working. We are now able to communicate between scripts, and we are doing this by, first of all, creating our balloon manager script with the variable and the function. Then in our balloon script, we have a variable that is keeping track of that node which contains the balloon manager script. So down here, when we want to access a function or variable from the balloon manager, we simply enter in the variable which is referencing the node, and then go dot increase score to call that function. Now, let's go ahead and make a few copies of our balloon, but before we do that, let's go ahead and save it as a scene, because if we were to duplicate this balloon a number of times, all of these balloons are not in the same scene, meaning that if we change a property in one of these balloons, such as the scale of the model, that change won't be applied to all the others. So what we want to do is delete all of these duplicates and instead select our balloon that we have created, right click on it, and go down to where it says Save Branch as Scene. We're then going to go to our balloon popper folder and save this as balloon.tscn. Now this balloon is a scene, meaning that if I make some copies of it, so we can go ahead and duplicate it a number of times here. Okay, let's just duplicate this like so. There we go. Now, if I go ahead and make a change to one of these balloons in the scene file, that change will be made to everything. So to open the scene file, we can go to the balloon here in this scene window. And you should see there's this little icon here which says open in editor when hovering over it. Well, let's click on that, and that's going to open up our balloon in its own scene, okay, because this is now the balloon scene. So if I then select the model and, for example, change the scale like this and save, if we go back to the balloon popper, all those instances of the scene now have that change applied. But let's, of course, undo that in the scene because we don't want that strange scaling taking place. And there we go. So now if we press play and have a look at the output, when we pop our balloons, it goes 1, then 2, then 3, then 4, and etc. But one thing we do need to change is the camera position, because right now the camera is a bit strange, okay? So let's go ahead and move that around. So I'm going to select our camera 3D, and I'm just going to move it so that all of the balloons are nicely in view. We can also change some other properties, such as the field of view, or FOV, to make it a bit more narrower. I might bring that to around 40, just to give it a bit of a nicer perspective. There we go. We can then play that, and I think that looks a bit nicer here. We can even then move our camera a tiny little bit, so you might want to move it over a little bit as we are going to have our score text on the left-hand side, which we might want to save some room for that. We can then go ahead and duplicate our balloons a bit more. There we go. Select our camera again, make sure everything looks good, and that is our final result. Now we are able to click on our balloons and make them pop. Okay, so in the next lesson, we are going to be working on our score text, because right now we can only see our score once it's printed out to the output. But if we are playing our game, we want to have some text on screen so we can actually see what our score is live. So that is what we're going to be working on right here. Here. 2, and then dot, and we can then call a function, or we can access the score variable, but I'm going to go increase score. We can then give it our score to give variable. Variable, which is the amount of score we give when popped, and that should then work. So I'm going to save that, press play, and see if it works. So keep an eye on the output down here. For a number to pop up. That if I make Welcome back, everyone. In this lesson, we are going to be adding our score text so that when we play our balloon popper game, we can see in the top left corner how much score we currently have whenever we click and pop a balloon. Because right now, as you can see, it is only being printed out to the output, and there is no way for us to actually see our score in game. So let's set that up. Now, in order to have our score be displayed on screen, we want to use a node that is going to render text to our camera or to our screen. Now, for this, we need to look at a new node type. So if I click on the Add Child Node button at the top left corner of our scene dock, you'll see that we have a large list of nodes here. Now, in Godot, there are three main, I guess you could say, categories of node colors. We have blue nodes for 2D things such as camera 2Ds, sprites, collision 2Ds. We then also have red nodes, which represent 3D things, such as collision shapes of 3Ds, 3D models, lights, 3D cameras, raycasts, all those things. But you'll then see that we have a third category of green nodes, which are known as control nodes. Now, control nodes are what we use to basically build up our GUI or UI elements. And these are essentially text, buttons, containers, images, things that we want rendered on our screen and things that we can interact with, such as buttons, input fields, all these different things that you want to build up your game's UI. Now, there are quite a lot, as you can see here, but the one we are looking for is a label, okay? So we're going to click on create, and what you notice is that when we create the label and have it selected, it is going to change our view over here into 2D mode. At the top, you can see 2D mode is currently selected. If I go ahead and select any of these red 3D nodes, you'll see it switches us over into 3D mode. And then if I select the label again, it'll go back to 2D mode. And this is because when it comes to UI elements, these exist on a 2D plane. Remember, these are elements that are being rendered to our screen, okay? They are being pushed up and rendered on our monitor or on our phone or on our TV. So they exist in a 2D space. So here is where we can basically position them, scale them, and basically define how we want them to look inside of our game. Now we can zoom in and out with the scroll wheel and hold middle mouse to pan around. And you'll see that there is this blue outline of a rectangle, and this here is basically the dimensions and aspect ratio of our screen. So you can see up here in the top left corner, if I zoom in, we have this orange rectangle, which is currently the container that represents our label. And there are these number of different orange circles surrounding it. Now, if I click and drag on these circles, you can see that I can actually resize this UI element. Okay, I can make it long, I can make it tall. So this is how we can change the size of it. Now, to actually give it some text to display, we can go over to the inspector, and you'll see there is this text field here. Basically, whatever we write in here is what gets displayed inside of the labels container, as you can see. So what I'm going to do is I'm going to write score, colon, space, and then have a number, for example, 10. So this is what our score is going to look like. Now, what we can do is save that and press play and see what it looks like. Now, there are a few issues. First of all, the score is crammed right up in the top left corner. Second of all, it's very small. And third of all, it is kind of hard to see because it blends in with the background as well. So what we're going to do is first of all move it down a little bit so we can actually click and drag on this rectangle to change its position. As you can see, I can drag it down and move it around. So let's move it a bit inwards like so, maybe resize it a little bit. But as you can see, resizing the box does not change the font size. To change the font size, we have to go over to the inspector, down to the label settings property, and we basically want to assign a new label settings here. We can then open that up by clicking on it, go over to font, and then font size. Now, by default, it is 16. I'm going to change this to maybe 32 or perhaps even 48 to make it a bit bigger. Oh, 48, there we go. Now, if I save that and press play, you'll see that our font now is a lot larger, but still it kind of blends in with the blue background. So what can we do to change that? Well, we could of course start by changing the color by clicking on the color property down here, and this is going to open up a color wheel where we can go ahead and change all sorts of different properties here. We can change the color sliders to basically whatever color we wish, so I might make it a nice green, something like that. Save it, press play, and there we go. But again, it still blends in the background, so let's actually make this, we'll make it a nice red. There we go. I think that'll stand out a bit more, like so. Okay, so we now have our score text. Let's actually rename the node here in this scene doc from label to score text. And the next step is to actually make it change value when we pop our balloons, because right now we can pop our balloons and that score text is basically static. It's not changing whatsoever. So how do we actually make it change and adapt to our score? Well, let's go over to our balloon manager script, And inside the Balloon Manager script, we are going to create a variable which is going to reference this score text label node. So here I'm going to create a variable called score underscore text of type label. And then inside of the ready function, just like we done with a variable manager, well, let's go over to our Balloon Manager script. Here I'm going to create a variable called score underscore text of type label. And then inside of the ready function, just like we done with our Balloons Manager variable, we are going to basically assign this variable to this node right here. So to do that, we can simply go score text equals and then drag in the node to create a reference to it. And then down inside the increase score function, what we're going to do is delete this line where we are printing the score to the output and instead replace it with this. We're going to go score text dot text to access that property here, and then go equals, and then basically what we want to do is have it say score colon, a space, and then our actual score. Now to do this, we can simply add in a string which says score colon space and then plus score. But this is going to result in an error, and the reason why is because the text property is of type string, and what we are doing here is trying to combine a string with an int, which is going to result in an error because we can't really put those two together. So what we need to do is convert the int to a string, because when we add two strings together, it basically just attaches them to one another. So what we need to do is before score, write str and wrap this in parentheses. str is essentially a function which converts whatever parameter we send over into a string. So we can send over a float, an int, a boolean, and it is going to convert that into a string value, which can then successfully be combined with our score string right here. So if I save this and press play, now when I go ahead and pop the balloons, you can see we have a score of 1, then 2, then 3, then 4. So that is how we can set up our score text. Now, one final thing we're going to do is make it so that when we press play, our score is not going to display 10 at the start of the game. It's going to display, well, 0. And to do this, we are simply going to go into the ready function. And after we assign the reference to our score text, we're going to go score text equals, and then just go score colon 0, okay? Oh, and we need to go score text dot text, okay? Score text dot text equals this. Now, if I press play, you can see that my score is 0 at the start of the game. And I can then pop balloons, and it is going to increase by 1 as we go on. Rendered on our screen and things. So let's set that up. You'll see that we have a lot of 3D things. And you'll see with our balloons manager variable, the ready function, just like we done with our balloons manager variable, we are going to basically assign this variable to this node right here. So to do that, we can simply go score text equals, and then drag in the node to create a reference to it. And then down inside the increase score function, what we're going to do is delete this line where we are printing the score to the output and instead replace it with this. We're going to go score text dot text to access that property here, and then go equals, and then basically what we want to do is have it say score colon, a space, and then our actual score. Now to do this, we can simply add in a string which says score colon space and then plus score. But this is going to result in an error, and the reason why is because string together score essentially a send over a float. An int, a boolean, and it is going to convert out when I go ahead and pop the balloon. Now to go score text oh, and we need to go score text dot text. Okay. Okay, score text dot text equals this. Now, if I press play, you can see that my score is 0 at the start. Hey everyone, in this lesson we are going to begin setting up our second mini project, which is going to cover physics inside of Godot. Now this mini project is going to look a bit like this. We are going to have our player in this environment with a bunch of different crates around them. Then we'll be able to click on the screen and that will push our player in that direction, sort of like if you were to hit a golf ball with a golf club, it's going to throw them in that direction, and the player is going to be able to collide with the boxes and push them around, sort of as if they are all on a piece of ice and everything is slipping around slightly if they get hit. So we're going to create that little fun game, and through this mini project we are going to learn about physics inside of Godot, okay, utilizing the rigid body 2D node as well as looking at mouse inputs. So let's jump into the project and get started. So I'm going to start by creating a brand new folder down in the file system. So I'm just going to right click, go new folder, and this one is going to be called physics, okay. Then inside of this physics folder, we need to create a scene to house our physics minigame. So for this, I'm going to go up to scene at the top left corner, go down to new scene, and then I'm going to choose the root node to be 2D. Now, when we are talking about physics, there are going to be two distinct types, 2D physics and 3D physics. Now, 3D physics, of course, is going to differ from 2D in the sense that there is one extra axis, but in general, the two are essentially the same in terms of their principles and the types of nodes that we'll be covering. So I'm going to call this node main, and then I'm going to save the scene to our physics folder as physics.tscn. Okay, just like that. So now it is in the folder. Now, the next step is going to involve importing some assets, because with our little mini project here, we of course want to have a player and some crates. Now, you can of course create those textures and sprites on your own, but if you want to follow along with the course directly, then again, in the course files tab, there should be an assets file that you can download, unzip, and then inside you should see a physics folder. Now, inside this physics folder, there are going to be two assets here. There's going to be a crate image and a physics character image. What I'm going to do is select them both and drag them into our physics folder, just like that. So now we have our crate.png, and if we double click on it, we can even see in the inspector a little preview image of it and our physics character over here. Okay, now, how do we actually go about adding these into our scene? Well, let's start with our player, okay? Our player is going to be a physics object that we want to be able to push around in our scene and have collide with the crates. Now this is going to be made up of three nodes. A rigid body 2D node, which is going to control the physics, the velocity, the drag, stuff like that, the mass of our player. Then as a child of that node, there are going to be two more. A sprite node, a sprite 2D, which is essentially going to render an image to the screen, and a collision shape 2D node, which is going to give that player a physicality in the world. So let's start by going and creating a new node here of type rigid body 2D. Okay, and you can see down here in the description it says rigid body 2D implements full 2D physics. Okay, so we are going to click on create, and that is going to create that node right here. I'm going to go ahead and double click on it and rename this to be our player. And you'll see that we have this little warning sign on the right hand side. Now, the reason why is because for this rigid body to actually function, we need to give it what is known as a collision shape, meaning we have to define what its boundaries are, because if this rigid body has no collider, then, well, it's simply just going to exist in a world and not be able to bump into anything. Okay, so there's no real point of having a rigid body that way. Now, on the right hand side in the inspector, you can see we have a large number of different properties for the rigid body 2D. We have mass, gravity scale, we have mass distribution, we have linear velocity, angular velocity, all these different things we can modify here in the inspector as well as in script. And there's even more things that we can access inside of scripting. So what we're going to do is I'm going to press W, so I go to the move tool, and we can see that our player is centered in the world, which is great. Now we need to go ahead and give them a visual, okay, a sprite. So what I'm going to do is go over to my file system and go down to the physics character. Now, like I said, we need a sprite 2D node in order to represent our player's visuals. Now, we could go ahead and create that, but an easier way of doing that is by dragging in our physics character PNG into our scene and letting go, and that is going to create the sprite 2D node right here. Now, I'm going to rename this to be sprite, so it's a bit simpler, and I'm going to make it a child of player. So I'm going to drag it over player to make it a child of player. Now, wherever player goes, so will the sprite follow. We also then need to center the sprite so it's on top of the player's origin position. So let's go over to transform, and then down in the position property, I'm going to set the X to be 0 and the Y to be 0 as well. So now our player is centered. But there's something that's a bit weird. We're working with pixel art here. If I double click on the physics character image, you'll see that this here is what we want to look like, but it is blurry. Why is it blurry? Well, the reason why it's blurry is because of the way that Godot is rendering images by default, okay? Because if we have a larger image, maybe a sprite that is, let's just say 64 by 64 pixels, then you don't want those little jagged edges to poke out and become obvious. You want to smooth those edges around. So by default, Godot does something known as bilinear filtering, which essentially just makes it so that when we are rendering these big pixels on our screen, we are essentially sampling the color between the neighboring ones to get a smooth transition between pixels, which, as you can see, creates a blurry image. But we don't want a blurry image, so how do we fix this? Well, what we need to do is go up to the project button here, then go to project settings. Then in project settings on the left hand side, we're going to scroll down to where we have the rendering section and go over to textures. Then here where we have our default texture filter, we're going to change this from linear to nearest. Now, if I close out of this, you should see that our pixels are nice and crisp, okay? It's no longer doing any of that filtering to smoothly transition between pixels. Close out of this, you should see that our pixels are nice and transition between pixels. It's rendering each pixel as they should. Now, with our player, if we select the player root node here, the rigid body, and press W, we can then move it around. Now, make sure that if you have your selection tool and you click on the player, don't move that around straight away, because if you click on the player, it's going to select the sprite, and we want the sprite to always be at the center of player, so just keep that in mind, okay? Make sure that whenever you're moving your player around, that you are moving around that rigid body parent, and use the move tool with the keyboard shortcut W to make that a bit easier. Okay, now one more thing we need for our player, and that is going to be a collision shape 2D. So I'm going to right click on player, go add child node, and I'm going to search for a collision shape 2D right here. Now this also has a warning basically telling us we need to give it a shape. So if we go over to the inspector, you can see we have a shape property. I'm going to click on the little arrow and set this shape to be a new rectangle shape 2D. Now we have this blue rectangle appearing in our scene here, and we can actually click and drag on these little orange handles to basically resize this collider. So I'm just going to make it fit the bounds of our sprite right here, and there we go. So now we have our rigid body player with a sprite and with a collision shape to define its bounds. Now, if we go ahead and press play, now I'm not going to click on the play button because I think we set our current scene to be the balloon popper, but if we click on this one on the right hand side, which says run current scene, that is going to run whatever scene we currently have open. Now, if I click on this, what you notice is that our player is all of a sudden just going to drop down. Now, we don't want that. First of all, we need to make our player not fall down with gravity, and we need to have our camera a bit zoomed in, because right now, whoops, wrong one, because right now our camera is very zoomed out. So in the next lesson, we're going to look at setting up our scene to make it look a bit nicer. So thanks for watching, and I'll see you all then. Welcome back, everyone. Let's continue on with setting up our physics mini project. So we need to make it so our player will not fall down when the game starts. Now, the reason for that is if we select the player and go over to the inspector, you'll see here that we have the gravity scale property, which right now is set to 1, meaning that 100% of gravity is going to be applied downwards. Now, if I set this to be 0, then that means no gravity is going to be applied. So if I press play, you'll see that our player is going to stay there in the middle of the sky, or the air, or the floor in this case. Now we need to make it so our camera is zoomed in on the player, because right now it's kind of hard to see where they are, and moving them around will be, a bit confusing. So for this, what we're going to do is create a camera 2D node, because right now when I press play, what we are currently seeing is, if we zoom out, you'll see that there is this blue little outline here, and this basically represents our screen in terms of pixel size. So this right here is what our screen is currently rendering, but we want to have our own little camera where we can move it around and we can zoom in as much as we want. So for this, I'm going to create a brand new camera 2D node. And this camera 2D, you can see it is going to appear as this purple box right here. Now, if I save this and press play, you'll see that our viewport is now in the center, with 0, 0 being directly here in the middle and the player being just to the bottom right of that. As you can see here, that purple box here. We can then also zoom in. Now, to zoom in, we want to go down to where we have the zoom property right here, which is an X and a Y. We basically want to change this from 1 times to a 3 times zoom, and this is going to zoom us in a lot. We can even make it a 5 times zoom, or whatever number you wish, but I'm just going to keep it on 3 for now. So if I go ahead and press play, you can see our player right here. Now, we've got that set up. But one more thing I want to do is change the background color. Now, the background color is defined by our project's clear color settings, because when we have nothing to render, Godot renders this gray color, okay? And this is essentially the color that gets filled in with filled into all the pixels on our screen that aren't currently aimed or pointed at something, okay? That is known as a clear color. Basically the color of the void, you could say, in your game. So what we're going to do is go up to project settings, and then down here in the rendering section, we're going to go to the bottom where we have environment, and here you'll see we have our default clear color. Now I'm going to select this, and I'm going to make this a very darkish, maybe we'll make it a sort of darkish red, something like that. And there we go. So now if we save that and press play, you'll see that our player is now on this darkish red background, which is pretty good. So the next step that we want to do is make it so that when we click, our player is going to be launched in the direction of our mouse cursor. Okay, so how are we going to do that? Well, first of all, we need to create a script for our player right here. So to do that, what we're going to do is select our player, then go over to the inspector. Down at the bottom, we're going to go to where we have script, and we are going to create a new script here. Now, this script I'm going to call our physics player, so physics_player.gd, save it in our physics folder, click create, and there we go. Okay. Now, this script is going to be fairly simple. We're going to have one variable and one function. The variable, we can write it right here, is going to be called hit force of type float, and we'll make it 50 by default, 50.0. This is essentially the amount of force we are going to apply to our player whenever we click. Okay, so if we click in a certain direction, we are going to apply 50 units worth of force to that player in that direction. Now for detecting clicks, we are going to do this inside of the process function. So if we're at our func process with delta as a parameter, essentially the process function gets called every single frame. So every single frame, we are going to be checking to see if we are clicking down with the left mouse button. Now to do that, we can simply go if input dot is underscore mouse button pressed, and then here you'll see we have a list of all the different mouse buttons we can choose from. I'm going to go mouse button left, then we're going to run this code. So essentially, if we click with our left mouse button, this code inside the if statement is going to run. Now, what do we want to run? Well, essentially, we want to, like I said, move the player in the direction of the mouse. Now, for that, we need about 3 things. First of all, we need our mouse position. We then need to calculate the direction to that mouse position, and then we need to actually apply the force. So I'm just going to write the comments out here. So here we go, get mouse position. Then we want to get mouse direction, and then we want to apply the force, okay? So these are our 3 steps. So first of all, get the mouse position. How do we get our mouse position in terms of where it is in the world? Well, for this, we are going to create a variable here. I'm just going to call this one mouse underscore pos, and this is going to be equal to get global mouse position, okay? This function right here is very handy. This basically returns a vector2 with an x and a y property that basically pinpoints where exactly in our world our mouse is. It's going to give us the x and the y. Then what we need to do is get the direction of that mouse position. Now, by direction, I essentially mean what is the direction from our player to that mouse position, okay? So if our mouse is over here, that means the direction will be up. Down here, it will be down. Here will be left, here will be right, and here would be somewhere in between up and right. Now, this is going to be in terms of a vector. So, for example, this here is what it would look like, okay? We have our player here, and if our mouse is to the right, that is going to return us a direction vector of 1 on the x and 0 on the y. So basically, where is this mouse relative pointing from? Now, if we have our mouse up and a bit to the right, then this vector will return 0.2 on the x and 0.8 on the y, okay? And this is essentially giving us a direction that has the x and the y, if added together, equal 1. This is known as a normalized vector, which basically means, like I said, the magnitude or the sum of the vector's parts equal 1. This then makes it easy to multiply it by other values to change the length of that direction. So in the next lesson, we will be looking at how to calculate our mouse direction and then apply the force. Okay, so to calculate our mouse direction, what we want to do is create a variable I'm just going to call dir, short for direction. This is going to be equal to our current player's position. Now to get the player's current position, we can just write down global position, and this is going to essentially return the position of the node that this script is attached to. Now, since this script is attached to our player, this is going to get our player's position. Then we want to go dot direction to, and then we give it another position. In this case, it's going to be mouse pos. Now, this is going to return a vector2 that is going to represent a direction pointing to our mouse. And then finally, what we can do is apply that force. Now, to apply the force, we want to call the apply impulse function, okay? Now, apply impulse is a function that is built into the rigid body 2D, and since we are attaching our script to a rigid body 2D node, we are extending it, as you can see at the top here, meaning that we have access to its variables and its functions. So apply impulse is a function on the rigid body 2D, and we essentially give it a vector, and that is the force that is then applied. So this is going to essentially be the direction multiplied by the hit force. Because the length of the direction vector is always going to equal 1, so if we multiply it by hit force, that means that the force we are, or the impulse we are applying is going to be 50 in that direction. So if I save that, then press play, we should see that when I click, our player will zip off in that direction, which they're kind of going very fast and very fast. So how do we make it so that our player kind of moves, but then they kind of stop? They come to a steady stop. Well, we can do that by changing the player's mass. So if I select my player node, go to the inspector, you'll see here we have a mass property. This is essentially how heavy the player is. By default, they're 1 kilogram. So if I change this to be 5, for example, they are now going to be 5 kilograms. So we can press play, and you'll see that the player is now moving around a lot slower, okay, as if they weigh a lot more, which of course they do. But again, you can see when I have them move, they are moving forever at that speed, which is not what we want. We want the player to basically move and then come to a stop, sort of like a pool ball on a pool table. Well, to fix that, we can go down to the linear section and change the damp. Now, the damp is essentially like air resistance, okay? If something is moving, that thing is going to gradually slow down over time. Now, right now it is set to 0, meaning it is just going to keep on going at its original speed forever. But if I change this to 1, now if we save that and press play, you'll see that we can click and our player is going to move, and they are going to slow over time. Now, you might want to be able to modify that property when you are in game right now. Now, a way of doing that is by using the tools that are provided at the top of the game window here, okay? You can see right now we're in input mode, meaning that we can click and use our keyboard, our mouse, our controllers, whatever sort of inputs we have to move our players and interact with our game. Now, if I switch this over to 2D mode, this means all of a sudden we are in a debugging mode that allows us to select nodes. And when I click on the node, you'll see that it gets highlighted in the inspector right here. Now, when I click on our player, you can see it is selecting the collision shape 2D, which is not what we want to select. We want to select the rigid body node, not the collider. So what I'm going to do is go up to the top here, and you'll see we have selected select mode. But we want to go over to show list of selectable nodes at position clicked. So we'll select that. And then if I click on the player again, it will pop up with this little drop down, which shows all of the nodes at that mouse position. I'm going to select player. And then what I'm going to do is I'm going to go over to the inspector and we can begin changing these properties. So I might change the mass over to 10. Go back into the game here. Click on input at the top left. And now our player has a mass of 10, okay? Or we could bump this up to a very high number, maybe 100. And let's just see how slow our player moves now. As you can see, they are barely moving when I'm clicking, okay? Which is kind of fun. Now, if we go ahead and stop playing this by clicking on the stop button right here, what you'll notice is that those changes do not get applied, okay? So that is a great way of modifying your game as you are playing without having to worry about undoing those changes later on, okay? You can see my mass is back down to 5. So yeah, when you're playing your game, it's fairly a quick process of changing over to 2D mode to select your nodes and then modify those properties, test them out, and if you like them, you can just note them down, okay, for later on. But if you make a mistake, if you change something that you didn't mean to, don't worry, when you stop playing your game, those changes will be reverted. Now, in the next lesson, we are going to be looking at setting up our crates. These are going to be rigid body items as well, that are basically going to be constructed in a very, very similar manner to our player. We're going to have a rigid body parent, a sprite child, and a collision shaped child. Now, as a bit of a challenge, I want you to go ahead and attempt to create the crate right here. Okay, remember, it's going to have 3 nodes, a rigid body, and then a sprite 2D as a child, and then a collision shaped 2D as a child as well, okay? And we have this crate PNG to utilize as well. So have a go at setting that up, and I'll be right back to see how you're done. select your nodes, and then modify. Alright, so I hope you had a go at that challenge. Pretty much for the crate, this is what we need to do. So, first of all, let's create a brand new rigid body 2D node, which is going to give our crate physics and the ability to collide with things. Then I'm going to rename it to be crate, just so it's easier to understand what it is. Next, we need to give it a visual, so I'm going to drag in the crate PNG image to create a brand new sprite 2D node, which I'm going to rename to sprite. I'm then going to make it the child of crate by dragging it over the rigid body node. With the sprite, we then want it to be centered, so I'm going to set the transforms position to be 0 on the X and 0 on the Y. And then finally, we're going to add a collider. So I'm going to right click on crate, add child node, and I'm going to create a collision shape 2D node. Let's then give it a shape over here in the inspector. I'm going to give it a rectangle shape. And if we zoom in, we can then go ahead and define exactly how we want it to look. There we go. Something like this. Now, if we go ahead and press play, what you'll notice is that the crate will just fall down, because once again, we need to disable gravity. So on the crate, if I go to gravity scale, let's set this to be 0. And we also need to go down to linear and set the damp. Now, if I set the damp to 1, you'll see that this isn't exactly what we want. So if I go ahead and press play and I move over and hit the crate, you can see the crate is going to keep on going for a bit longer than we want it to, okay? So I want the crate to fly, but then sort of stop a bit quicker, I guess you could say. So to do this, I'm going to bump the damp up to 3, so it's going to be 3 times as resistant to the air, I guess you could say. Just like that. You can see we can push it, and when we stop pushing it, it kind of just stops. There we go. So now we can experiment with physics inside of Godot, but we don't just want one crate, we want many crates. So what I'm going to do is save this crate as a scene, so then we can duplicate it as many times as we wish around our camera view. So I'm going to click and drag crate and bring that down to the physics folder. This is another way of saving a scene. Click save, and there we go. So now let's just go ahead and duplicate these crates many times. Physics for camera, so then we want many with just many times we save, and there we go. Folder. This is another way of saving a scene. Click crates many times. And there we go. Now, if I press play, you'll see that we can then move and basically just start knocking these crates out of the way. So, that is going to be the end of this mini project right here. Now, if you want to expand upon this, I'd recommend looking into maybe adding in a second type of physics object that might be a bit heavier, maybe a rock or a stone, something that you might want to increase the mass of, just so that when we hit into them, it's going to take a lot more effort to get it moving, okay? So have a go at setting up different physics objects. If you wanted to create a platformer type of game where you have things falling downwards, then definitely look at increasing the gravity scale on your objects, as that is going to allow you to have that sort of downwards gravity and jumping. But as we have here, we have our little physics game set up. Feel free as well to experiment with more of the rigid body settings, exploring what they do. Remember that you can hover over these properties like this, and it will give you a little description of what each of them do.